Hi, everyone. Hello. My name is Paul Irish, and we're going to dive into the Chrome DevTools. Since Google I/O last year, there's been a lot of work put into DevTools, and I'm going to show just a little bit of some of the features that have landed. So the way that we're going to go into this, we're going to dive into some of the improvements made to authoring, just building out and working with the tools to iterate on your application or your site. Dive into what that looks like on mobile, and then dive into some of the groundbreaking performance features that really change how you can get insight and understand how to fix performance situations with your app. All right, so first up, I want to play a little bit of this video. This is Remy Sharp, and a bit ago he made a short video on kind of how he never even leaves the DevTools when he does development.
So what I'm going to do here is just make a few changes. Hopefully you already know about this. You can just kind of stick your mouse cursor straight in, and we can just go to blue. And if I hit Command S.
So what he's showing here is actually two separate things. One is that he has live edit in the JavaScript. Any changes he's making in the JavaScript are immediately patched up to V8, and it starts evaluating the new code. And the second feature, separately, is he's making these changes back to disk and saving them so that they persist to disk. We like this. We think this is really powerful. And if you've seen the Brett Victor talk, having an environment where you can iterate live against your production application that you're building really changes the whole development lifecycle. So today I'm going to share with you something called Workspaces. But actually, I have a problem with this slide. First of all, there's a capital. OK, 1 second. I'm just going to fix this. OK, let's see. We're going to dive into here. And then actually, the styling is not totally keen. We could make this better, I think. I'm going to add some text shadow, probably. Let's give it some of this. Yeah, just like a little glow. I like that. Wow. Maybe change up the color. Let's see. I'll just bring it a little bit whiter. And bump up the font size. Oof, line height. Sheesh. OK. 1.1 sounds about good. Yeah. All right, so I made these changes. I should probably copy them. Or maybe I'll go over here, and I could copy them over from here, go back to Sublime, and let's see, we're in my default CSS. Texture line height. Wait. OK, let's see if I can get this on screen at the same time here. OK, yeah. Sure. So line height and color, let's whiten that up. And let's see. And add a little bit of box shadow. I don't know. It's 1 pix, 10 pix, black. Seems good. Come down here. And what you're seeing, actually, is so all my changes that I'm making in styling, all my changes that I'm making here in the style panel are persisted to disk, and I immediately have them over here. Now, I can make my edits here, or I can come over here and actually just kill this box shadow and tweak my line height. But I have the editability in both places. I can also come back, say, for instance, to Sublime. Maybe I'm going to make my change down here. So instead, I'm going to kill the box shadow down here, and we'll change the color over to indigo. I like that style. Come back, and immediately my change comes up in the DevTools. No refresh. So I'm really keen on this, and I think it's really powerful. But it's backed up by a bit of work. So one last thing, the capitalization that I didn't even get to. Let's take a look at that. So these are actually HTML styles, HTML slides, but I'm using Markdown to actually generate them. So if I want to change this, I should probably edit my Markdown. So what I'm going to do is just hit Command-O inside here, bring up my slides.markdown, and inside here, so this is just my Markdown source. I'm going to change the capitalization, hit Save, hit Refresh, And we got my changes in place here. So this is really powerful, and we're really excited about what we can do here. Workspaces allows you to map what's coming into the browser to the local file system. So in this case, this is the workspace for my slides. I have the entire local file system, and that's been mapped by DevTools to what's coming in the browser. So I can edit my JavaScript, my CSS, my HTML, my Markdown files. Even the DevTools engineering team who's building this edits their C++ bindings directly inside the DevTools. The style changes that I'm making inside the styles pane persist. I can edit anywhere the changes are kept. I can undo, redo any of the changes in here, which is just Command-Z, Command-Shift-Z. And this is great because I'm able to maintain my context for styling. So I don't have to be bopping in and out of a different editor to make these changes. I can make them all here in one place. All right. So this is looking pretty good. I'm going to move on. Last year at I/O, we asked everyone what features you wanted inside of DevTools. And one of the top things that people wanted was support for Sass. Because you're editing in Sass, you're authoring there, but then in the DevTools, you're seeing CSS, and you kind of need to manually map back and forth. So this is something that we've been working on, and I wanted to show you how this works. So I'm going to bring up a little copy of HTML5, please. This is a site with a small Node backend, but the styles are written in Sass. And we want to take a look at how that works. So let's say this little use badge right here. Now, normally, if I am looking at the styling, I'm going to see something like this, right? So use, we got the green, box shadow, border radius, border right, and background. We're all using this green, and in fact, it's using just a little bit darker as it goes down. Now I can click over to see my CSS, but as I said, this is compiled from my Sass, so it's not very helpful. So let's turn on Sass debugging. So I'm going to go into DevTools settings. I like using the question mark for this. Quick little shortcut. Go into experiments, turn on Sass debugging. And now I'm just going to refresh the page so that this is all looking good. And now the first difference that you're going to see is that right here, we're listing the original place inside the Sass file where this was found. So I can click over to that, and we're looking inside my Sass file where this selector was found. So we got my use, and it looks like we're applying a mix-in inside here. OK, cool. But I actually want to change this green, so we're going to have to do a little bit more hunting. So as I hold down the Command key, I actually get a little bit of visual feedback. As I hover, I get these little underlines. So I'm going to try clicking background. We're going to jump immediately into where that mix-in was defined. I can see my background, my box shadow, my border right. All right. But yeah, we got this color. It comes in. It's getting darkened. And I want to edit the color. So let's do that. I'm going to command click on the color itself. And over here, we dive into the variables.scss file where the color was actually defined. My cursor goes right to the definition. So now, let's see. I will probably want to make a change. As I said, I'm really into Indigo lately. All right, I'm going to hit Command-S. Now, one of the cool things that we have set up is that if you have a Sass watch set up, so you're just watching, you have the daemon sitting there waiting for any changes to disk. We can actually use that. And then as new changes come into disk, we can apply them. So let me give this a shot. Just going to come back in here, make sure that that setting is on. OK, auto reload CSS upon Sass save. Come over, and it looks like there we go. Nice. All right. So I can make any changes to my Sass right here inside the DevTools, change the color. Maybe I should go back to that green. It's probably better than all these changes. Just hit Command-S. And due to Workspaces, as we saw before, my local development folder is mapped to what's coming in over the wire from localhost. And so my changes are saved back to disk. And my watch picks it back up. And DevTools takes care of refreshing the styles right inside the browser. So this is really cool. We have full traceability from in the UI, from selectors, properties, variables, back to the mixins, the functions, the places in the original sources where they were defined. And in fact, this is powered by source maps. You've heard about source maps for JavaScript. This is the exact same technology, only used for CSS. And the DevTools team contributed the source map implementation into the core Sass compiler to enable this functionality. And we have the automatic reload of style sheet. So as you edit inside the DevTools, you can just keep going and see the changes as they come in. All right, so these two features combined really kind of change things. It really means that DevTools can become my editor. I can style as I type, whether it's in CSS or Sass. These changes can be persisted to disk because I'm mapping them right into my local folders. Inside JavaScript, I can reevaluate it on the fly with live edit. And where I author is where I debug. It's really powerful, and we're excited about what we can do now with this. All right, now that we've covered kind of taking a look at giving you more productive tools when authoring sites, let's bring that to mobile. All right, so last year, we talked about remote debugging Chrome on Android. Powerful stuff. But it does require a bit of command line hackery. So who is, raise your hand if you've debugged Chrome on Android? Cool, yeah, it's great. And raise your hand if you really enjoyed dealing with ADB on the command line and memorizing that little guy at the bottom. 1 second, this is why you don't do hotspots on your lock screen. All right, cool. So this little guy, yeah, not the most fun. So we thought that this could be better, and so this is our new kind of experimental UI for dealing with this. So first things up. Beforehand, you had to download the Android SDK to make this work. Now there's this little Chrome extension. See this guy? We're just going to click on this guy and start up ADB. So actually, the Chrome extension itself ships with ADB, which means I can just turn him on there, and he's going to turn on Gree once ADB is running. And this means I don't need to download the SDK whatsoever, just the 5 meg Chrome extension that takes care of this for me. All right, now I'm going to plug in my phone. Let's see. And that's my password. All right. I'm about to plug it in, and let me switch back to the screen, because it detects right away that my device is in. Awesome, good. So now that that's in, let's check it out. So I'm going to click again and go to Devices, View Devices. What this takes me to is the Chrome Inspect page, or About Inspect. You might have been here before if you've had to download the background page for a Chrome extension or a shared worker. It shows you all the targets that you could debug. And now, any targets that you have to debug on a phone that's connected are going to show up here. So here's my Galaxy Nexus that I have connected, and we're seeing the page that I have open right here. So let's take a look. All right, rock and roll. So this is the full DevTools. Let me gum over to timeline, and I'm just going to record a quick timeline as I scroll the page. There we go. It's really powerful, and we're excited about having the full functionality of the DevTools available so conveniently. And this is not just the full functionality of the DevTools, but any Chrome extensions or DevTools extensions that you want. Before, didn't have available. Now, say, for instance, you want to run Google PageSpeed against your situation on the phone. Right here, my phone is actually still on 3G. And so I'm able to understand in real network conditions what Google PageSpeed is going to tell me. But there is still a problem. So let's say I switch back here, and I come over to this file. So before I was debugging HTML5 please, and it was coming over localhost. And sometimes I'm not able to have that available on my phone. Just doesn't come up. So we thought we could probably fix this too. So if I have this up here, I'm going to inspect this target and go into the DevTools settings. And you'll see here a new setting. It's called port forwarding. And so now I can just add in, I want to map over port 9000, get that going. And we'll come back over here. and refresh, and we're good. So this is fantastic because I can even use the functionality that I was showing before. If I want to use Workspaces and make a change, so this is the HTML of the page, and I'm actually just going to make a change to the source markup. Just hit Command S, Command R, and I come back over here, and we just load up the brand new version. Command R again, you know, for good luck. And we're good. All right, so I've just connected with a lot of ease to here. I have Workspaces, I have Sass debugging, I have a lot of power, and I can focus my development in improving this mobile experience, which is really fantastic. All right, so no command line setup. See all your debug targets in About Inspect. Great feature set available. Everything that's on desktop is available for Chrome on Android. And port forwarding to make this local development feedback loop really fantastic and smooth. All right. Now, bringing this back up. I've covered authoring. I've covered what we can do to make this experience better on mobile. Now dig into performance a little bit. There's fantastic features, and I'm going to cover a few of the brand new ones. But the first thing when coming to performance is that you really got to focus on the right priorities. Find your biggest bottlenecks and focus on those first. And the timeline is the best tool for this. And I want to show this with a good example. So here I have, this is like an infographic parallax site. And so what we do as we scroll down, we got this kind of orange circle growth. We got these white little guys that are going to physics kind of going out. We got this kind of section, this parallaxy. It's an attractive site. And then down here, a little bit more changes. But I'm going to come back up to the top, and now let's take a look at this inside the timeline. I'm going to bring the DevTools down to the bottom. You can actually just drag it down. All right. I'm going to start a timeline recording with Command E, and just scroll through the page. All right. Now, what's really cool about what the timeline tells us is it basically tells us the narrative of performance of this site. As I scrolled through, a few things happened. Up at the top, it was pretty quiet. There was just the headline. And then here, we got into this green section. What this was is a lot of draw calls. Time was spent inside draw and painting. And this is when all these orange circles are coming up and populating the screen. Then we get into a lot of yellow. And what this is JavaScript execution, of course. And this is coming in because of all the computation required to make this functionality happen. Then things are kind of pretty chill as we go through this middle area. We're mostly hitting our target of 60 FPS. So we're staying within our frame budget, no big problems. And then down towards the end where we have this kind of effect, we're getting kind of a cacophony of color. Lots of different things happening at once. Looks like a good amount of recalc style, layout, paint, and then also JavaScript all happening at the same time. But overall, we get this really great view of what the situations are. And first, I want to call out that this is not the only DevTools talk here at Chrome I/O. There's a lot of other talks, and some of them have already happened. But if you want to dive into how to figure out, when you have a lot of green, you're going to want to check out these talks from the jank-free talk and the device-agnostic development talk. Yellow, as luck would have it, is follow the yellow brick road to JavaScript performance. It just worked out really well. If you're looking at GCs and memory, there was a great talk earlier about Gmail's memory performance and how the Chrome DevTools help there. Compositing is great stuff, and also layout, excellent stuff. So dig into those talks as well so you can find out how to use these tools in more detail. But I want to show a brand new feature, and let me show how it works. All right, so we're looking at this little section here where we have all the little balls that are kind of about to move around once I start scrolling. And I'm going to record a JavaScript profile, because as we saw, a lot of yellow in that section. We want to know what's going on. All right, let's just try it. I'm going to hit Command D once this gets going. Come on. There we go. Nice. All right, Command D to start and stop really fast. And so what you get, is a JavaScript profile. And so we're seeing here in aggregate, where my costs were spent. And this is good. But in some cases, it doesn't tell the whole story. You're interested in a picture that kind of tells a story over time, and you're just seeing at aggregate level. But here, we can turn on the flame chart down at the bottom, and we get to see a different look. So this is over time where my time was spent inside V8. And in the zoom out view, you get a sense of, am I doing the same sort of operations over time? But I can also dive in a little bit closer and understand what's going on. So I want to point out a little bit on how to read this. Call stack is the y-axis, so height doesn't matter too much. What you're looking for is wide bars that are taking up time. In this case, it looks like, let's see, this little flame over here, we have a little bit of pub sub. It's not too heavy. But it looks like most of our ticks are inside of D3, inside of this quad tree view call. And then a lot of insert child's cost right here. So I'm able to get a good visual view of where our costs are. And then we can dive in and make some optimizations later. All right. We also have a new experiment for profiling canvas, and I want to show you how this works. So this is just a WebGL experiment, and we're going to open up the profiling panel, and we're going to select Capture Canvas Frame. Now, it just captured one frame of the canvas, and it's going to dig into all the draw calls. So here we're listing out every single draw call that's happened to that canvas, and we can just go down, 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 apply them one by one, and see how they affect and how this frame is built up over time. And then we can open up one of those draw calls and see all the functions that contributed to that specific draw. And if we want, we can click over to the sources panel to see the source of each of those functions. Now, this is just a platform. We have great recording to be able to instrument, record, and replay Canvas. This is both 2D Canvas and WebGL. Now, what really happens next is up to you. We could add a lot of features to this, but we're interested in your feedback to hear what would be most useful to make this great and improve the performance of your apps. All right, so 5 more key performance features. I don't have too much time, but I want to show them off pretty quick. All right, continuous repainting mode. Fantastic if you're seeing a lot of green in your timeline view. You have a lot of paint costs, and you want to find out why. Turn on continuous repaint mode. This is going to tell the browser to paint. And then you're able to turn off DOM, turn off different styles, see what is affecting your paints the most. In some cases, it's a little hard to see. Maybe box shadow and border radius are on. Maybe they're not too additive. It's a little tricky. So this is going to give you a lot of insight. The FPS meter has been in there for a little while, but it's getting a lot of upgrades. So you're able to see how fast you're throwing frames to the graphics context. Get a little histogram view over here, a min and max. And also the GPU memory. This is really important on mobile, where you only have a set amount of GPU memory. And if you're constantly evicting things out of the GPU memory, it might be slowing down how fast the user is actually seeing things. And this is going to give you a lot of insight. Show paint recs and layer borders. These are settings inside the DevTools. Great for understanding if you're getting a lot of paints, what is the size and shape of these paints? Maybe it's the entire screen is repainting every time you scroll. We want to understand that and find out why. In this screenshot, we can see that our little dataset div just got repainted. And we got a composite layer border around this side. This is actually the scroll bar, which the browser is now compositing on top of the page content. Object allocation tracking is brand new. This is basically taking continuous heap snapshots over time. And you're able to identify where objects are being created and identify the retaining path. Great if you're digging into the memory performance of your app. Layout thrashing is a big problem with DOM, with the web application's DOM performance. So a lot of times you'll be touching the DOM, it'll cause layout thrashing or reflows. And here we're able to not only see a few things. So in timeline, you're going to see a little icon if DevTools detects that this is a forced synchronous layout. It's going to tell you it might be a possible performance bottleneck. You're doing more layouts than you have to. The user's not even seeing the work that you're forcing. Then it's going to tell you the call stacks, why exactly the layout was forced, and why it was invalidated. You can dig into the sources right there and see the actual call that forced it. And now this is brand new stuff. Identify what nodes need layout, how many they are, what the total tree size that's getting reflowed is, and where the document root is. Sometimes the entire document is being laid out again. Other times it's just a partial layout. All right, so a lot of stuff here, and you can try it out today. We've just been working, put in a lot of work on the DevTools documentation. So there's a lot more that I didn't even show, and we have great docs to back it up. So I encourage you to check those out. And everything I showed today, all these features are available in Chrome Canary now. So you can go check them out, give them a shot, give us your feedback. All right, thank you guys very much. And we have some time for questions. So I'm going to invite Pavel up on stage with me. And if you have any questions, I encourage you to line up against the mics. Sir.
Hello. I was just wondering how much of this is available if you use GWT to develop the website.
GWT.
Google Web Toolkit.
It depends on whether you're using source maps for GWT. If you're using source maps, you get all the debugging capabilities. Source maps and Workspace are working well together. So you get pretty much all of it. You can save your source.
Integrated as the Sass you showed?
Yeah. So you'll need to take care of generating JavaScript of your Java. And you might need to add a bit of extra to reload it so that it was reloaded automatically. But you can edit Java. You can save it to disk. Source maps will be catching up. You can debug using Workspace and Sass in the time.
Cool. Thank you.
Yep.
Hi, Adam Crabtree from LinkedIn Mobile. So Chrome DevTools are amazing. They're awesome. But what would be even more awesome, right, is if we could use all these, the heat profile, performance profile in Node. And there's some community projects, Node Inspector, WebKit Agent, Node Agent, that have been doing a pretty good job. But the problem is they can't keep up with the development speed of the Chrome DevTool team and the V8 team. And I'm curious if there's any plans to support Node debugging, memory management in Node.
So Node Agent, I know Node Inspector, of course, is not as maintained as it was
dead.
Before. Yes.
Officially dead.
Node Agent is picking up where it left off. Great profiling capabilities. In fact, I was just talking to the author of it like 3 days ago about getting flame chart support inside there. Be trivial for him to add. Those are all done over the V8 protocol, so it's not too hard to bring in the front end, which is completely open source, just the web app, and hook up to the V8 protocol and bring in those features. So
at the same time, it's hard, right? Because there's no support for breakpoints. There's no support for stepping through code in Node WebKit Agent. And so I'm just curious if there was any desire for the Chrome team to actually enable remote V8 debugging.
So we are not using the old V8 protocol for debugging in Chrome DevTools at the moment. We are based on the WebKit or now Chrome remote debugging protocol. So it requires some native code supported in Node and exposing particular features, including support of the transport of the WebSockets for this whole story to work. So it's just an effort. We are happy to assist there or work with Node on making it greater, better, and faster. But it just requires some work.
Excellent, thank you.
Hi, I heard there were some experiments at integrating CodeMirror and ACE into the syntax highlighting. Is there any ETA where you edited with any of that?
Sure.
So CodeMirror, you can enable it today in settings, and you'll be using it as your default editor. Happy with anything we see, because we need to, we are kind of a unique situation where you need to be able to debug obfuscated Gmail, where lines are tens of thousands of characters. And at the same time, you want a rapid native feedback and feel for the editing. So we are still unhappy with everything we have. We are working on a hybrid approach that would address all the needs and make it the best editor.
Cool. Thank you.
Hey there. Great stuff. The Chrome extension that you showed off, I don't see it on the DevTools site. Is it out? Where is it? Is it just in your Git repo? Like, where is that? The Android thing that kicks ass. Like, how do we download it?
It's in my GitHub repo.
Should I clean that up?
Yeah, you could do that.
Well, this is how I always
So
get to it.
the little disclaimer, the way it works, it bundles ADB.
Right.
It bundles ADB and it works for Mac only at this moment. It may be easy to make it work on Linux, not as easy to make it work on Windows because of the USB drivers. We are working hard to resolve that and make it useful everywhere and convenient to everybody, but it's currently in the preview mode. That's why you don't see it on our web page.
Okay, thanks.
The editor features that you've shown, I think, will make it much more convenient to use a device like a Chromebook Pixel to do real web development. I'm wondering if the workspace features that you showed have file system access. So if you have like user local my dev files running on your machine, will you be able to edit those from the Chrome DevTools on the Chromebook?
So under the hood, it uses file system API that is mapping things directly to your file system. On any device that has file system, Workspace will work, including Chrome OS, where you can map it to your downloads folder or your drive. We are generally unhappy with our development story on Chrome OS yet, and we're working on it because important things such as version control integration are missing. So we want a complete, full-fledged story there. We're just not there yet.
Thanks.
Hello. First one quick question. So you were showing when you edit a file in your editor in Sublime, it reloads automatically in DevTools, and I guess not just in the DevTools, but like in the page itself, right? The question is, second question is more about how far do you think you will take DevTools in terms of editing? Like for example, I work on backbone applications where it'd be great if I could jump, to the definition of a method from one class to its superclass and kind of things.
Okay, ID features and refactorings. We are editing because you want it, and we started with the debugging. We considered ourselves as a debugging instrumenting platform, but we can see that there is so much value that can be added through adding basic editing capabilities that we are on this route now, and the time will show how far we would like to go there, but things like code completion are definitely in our plans.
One of the other things Chrome DevTools actually uses, you've heard of the Uglify minifier. When it was working on the 2.0 with source map support, we helped their crowdfunding contribution for that. And similarly, we use CodeMirror, CodeMirror is available, and the author behind CodeMirror has been working on a new kind of insight for static analysis of JavaScript called Turn, and we contributed also to that, and we're watching that project very closely.
Hi.
Great. Sir, in the back.
The things that you showed us with Sass are awesome. Do you have any plans to support other frameworks such as Less or Stylus?
So I should have pointed out that what I showed was abstracted style support. It's all based, as I mentioned, it's all based off of source maps, and so. Nothing in our implementation is specific to Sass. It's just specific to source map support. So if source maps are supported inside the compiler for either Less or Stylus, then DevTools will start working with them today.
Okay, thank you.
All right. Thanks, everyone. Appreciate it.